This is silicon, an element disguisedly running the whole world. It is in our computer, phones, and in almost every electric devices and gadgets. Silicon, which is a semiconductor, it's neither a conductor nor an insulator. It can work like an insulator at its purest form, but also conducts electricity under certain conditions. It has four electrons in its outermost shell that let it make bond with four other silicon atoms. At its purest form, it can't lose or gain electrons and works like an insulator. To conduct electricity, we have to add some impurities like phosphorus, and it's called doping. We add some phosphorus to silicon. Phosphorus, which has 5 electrons in its outermost shell, we see 4 electrons of phosphorus make bond with 4 other silicon atoms, leaving an extra electron. This type of doped silicon is called an N-type semiconductor and it's neutral in charge. Same in this case, we added aluminium to silicon. Aluminium has 3 electrons in its outermost shell, so it only make bond with 3 other silicon atoms, leaving a hole or a gap. Now combining these two different semiconductors, N-type and P-type, we see something obvious. Extra electrons in the N-type near to P-type tend to leave and fill gaps of P-type, and they successfully do it. But there is a catch. Those gaps that are filled create a neutral region with no charge called depletion layer. By making N-type positively charged because it lost electrons and P-type negatively charged because it gained electrons. Now the electrons from the N-type want to go to P-type to fill gaps, but they're repelled by the depletion layer as it is neutrally charged, creating a barrier between positive and negative charge. It stops the flow of electrons from N to P type. Now we added another N type semiconductor. Same happens here. The combination of these three called N, P, and semiconductor. Now the electrons cannot flow from N to P to N. To conduct electricity through it, we need to make the depletion layer thinner, and that's how semiconductor works.